Now we're going to hear from Paul Prince. Paul Prince is CTO of Mangstor, an Austin, Texas company. CTO of Mangstor focuses on high-performance flash storage arrays using NVMe over Fabric technology. These storage arrays support high-performance computing, or HPC, database, and other high-performance workloads. Before joining Mangstor, he was CTO for the Enterprise Product Group at Dell, responsible for the development of Dell server and storage technologies. And before that, he was platform architecture director for servers at Intel. On a personal note, Paul says that he enjoys water skiing on Texas lakes, including Lake Travis near Austin. So with that, let's hear from Paul. Thank you.
Thank you, Kate. Thanks. All right, thanks. So I saw a few people leaving because I know it's lunchtime, so I appreciate the folks that stayed hanging in here for the last keynote of the session. Hopefully it'll be worth your time. As Gene mentioned, I previously was CTO for Dell, and while I was in that role in the Enterprise Product Group, twice I came to the Flash Memory Summit and did a keynote. Now, when I did that, Tom's nodding his head. He remembers, hopefully with fond memories. When I did those keynotes, it was not in this giant hall, right? So the last one, if I remember right, was 2010. And obviously, we've grown. We as an industry, we as a technology have grown in a big way since 2010. And back in 2010, I laid out some challenges. And I think we've done a really good job as an industry on delivering those challenges to make Flash and SSDs really take off in the marketplace. Today, I'm going to up-level from mostly not talking at a device level, but talking at a storage array level, and in particular, talking about NVMe Express over Fabric, which is a new technology that many of you may have heard of by now, but hopefully most of you will know more about it when I finish than you did when you walked in here. And in particular, I'm going to try to talk about where it matters, and real-time analytics is a perfect example of that. So from an outline perspective, NVMe over Fabric, or NVMF, as I'm going to call it in this talk. Let's just talk about why we need it, why do customers care, a little bit about what it is, and then how it fits in the market, some example solutions, and then a little bit of future prognostication. So I love this graphic from ScaleDB that I found, which talks about really the intersection of high velocity and big data. We've been hearing about big data for several years now. And some conferences, it's all you hear about. But most of the big data discussions have been talking about the analytics and the act of getting that nugget out of this massive pool of data. But more and more, as we're talking to customers and we're seeing applications in the marketplace, as people try to use the big data they have and actually run their business, it's turning into an intersection of high velocity and big data, which you could call real-time analytics. So think about it from a CIO's perspective. CIO says, hey, I'm spending many, many millions of dollars on my infrastructure, whether it's in his own data center or whether he's outsourcing it to the cloud, spending a lot of money on it, and I got to get more business value out of it. So what does a CIO do? CIO hires a data scientist. And I saw an article from Harvard Business Review talking about this role of data scientist and how complex it is. And obviously a little tongue-in-cheek, Harvard Business Review 2 years ago said that a data scientist is the sexiest job of the 21st century. So there you go. If you're not in that career field, you might want to move there. But a data scientist is faced with all this incoming data. And the questions are getting more complex for him all the time, him or her. And the CIO is saying, I need the answer yesterday, right? So it's a pretty complex situation. I love this little graphic and note that I found from a Cancer Research Center project. And if you read that objective to identify full-length transcripts, et cetera, frankly, I have no idea what that means from a scientific research problem. But obviously the author understood what I understand, that she's looking for needles in a haystack of data, right? And that's really what NVM over Fabric is all about, is providing very fast access to the most interesting information in very large sets of data so you can do real-time analytics on it. So what is it? What is the technology NVM over Fabric? And let me actually back up to say what is NVMe as sort of a baseline. So most all of you will know NVMe very well at this point. But the simple way I describe NVMe when I'm talking to my customers is NVMe was defined as a standard interface to flash using PCI Express as an optimized way to move data to and from flash, and it really allows us to provide storage to our customers that removes the barriers of the legacy SATA and SAS buses, so they get much higher performance out of the underlying flash technology. Similar analogy really applies to NVM over Fabric, right? So it's an industry-defined interface that provides flash-optimized access, and it helps us to get past the legacy barriers of the traditional fiber channel and iSCSI SAN interfaces. It's really that simple. We were very happy. We've been a part of NVM Express for quite some time, and we're involved in the committee that's been writing the NVM Express over Fabric standard. And we were very happy to see it published about 2 months ago. You can see, hopefully the date on this, I think, says June 9th. So the version 1.0 of the NVMe over Fabric spec was released, and pulling a quote out of the press release, it says it extends the benefit of NVMe beyond rack scale architecture to data center wide fabrics supporting thousands of devices. Now, Mangstor actually has been shipping an NVMe over Fabric product for a full year. We won a Best of Show award 1 year ago at this show for our NVMe over Fabric storage array. Since the spec just got released 2 months ago, that's pretty obvious then that we've been shipping a pre-standard product. So 10 months of pre-standard product, now we're happy to say that we're shipping a standard compliant product. So let's talk a little bit about what it looks like from an underlying simplified software architecture model. So if you look at NVMe, you have one or more local SSDs. In my picture here, I show add-in card form factors, a couple of the cards there. And then that's all sitting in industry standard server, which may be Linux or maybe Windows. Both Linux and Windows now come with in-box NVMe drivers, so you don't actually have to load any software. You just load the OS and it's there. And that provides a block storage interface up to the file system, and then applications run on top of the file system. Very simple. And in fact, other than it being a different driver, that whole stack looks exactly the same as it would for, say, a SATA SSD. Now, it's great that it's industry standard interface, multiple sources, and you get great performance out of it. The downside, or the limitations of that, are the storage you populate is the storage you have, right? So if you populate one SSD that's a 800 gigabyte or a 1.6 terabyte drive, that's what you have. And you have no ability to get more storage unless you add more SSDs. And in fact, if you want more storage in that server and you add multiple SSDs to get it, if you want to create one large volume across that, you're going to have to do some software RAID in order to take advantage of that. So now let's talk about NVMe over Fabric. Sort of in contrast to that, if you look at this picture, the first thing that you should notice is that the NVMe driver becomes an NVMF driver, and I've moved my SSDs out of that local server into a centralized storage array, and I put in an RDMA NIC into the server on the left-hand side of the picture as you look at it here. But other than that, really, it's pretty similar, and in fact, the most important thing is that from an application perspective, nothing changed. So it's still presenting a block storage device interface up to the file system, and applications take advantage of it. So as far as applications are concerned, there is zero changes involved. It just is faster, and it's very large pools of storage. So the benefits, of course, with NVMF, just like NVMe, are multiple sources industry standard, which gives customers confidence. But unlike NVMe, now you get the added benefits of it's really unlimited storage per server, because you can put multiple arrays, you can aggregate across arrays. Any individual server can potentially have hundreds of terabytes or even petabytes of what looks like local storage to it. And you can scale the storage independent of the servers. So if you want more storage capacity, you add more storage arrays. If you want more compute capacity, you add more compute servers. But they don't have to be coupled together, and that allows for flexibility in purchasing and spend from a customer perspective. And because you can scale it independently like that, that allows you to share it very efficiently. We've had a number of customers that were looking at the option of populating an NVMe SSD in every single server inside their compute farm. And when they looked at the use of their compute farm, they said, well, the amount of storage we're going to have to put in every server is the peak storage that it will ever need. But with a shared fabric array, they can actually populate to sort of their average use rather than their peak use on every single storage array. So that allows for much more efficiency in the storage and in hopefully actually in cost savings and overall deployment of the solution. And then the last point on this slide is that HA is straightforward in the sense that now you can do things as shown in the picture like multipath I/O to the storage arrays so that you have no single point of failure on the fabric. You can spread your data across multiple storage arrays so that again you have no single point of failure on the array side. In short, it's many of the same benefits that our users have gotten used to with SAN-based storage, but it's much higher performance than SAN. So it's greater I/O performance certainly than SAN-based all-flash arrays, but surprisingly, what most people don't realize, it's actually greater performance than local NVMe-based storage. And let me walk you through that, explain how that works, because that's not necessarily intuitive. So I took this chart from a Tweaktown review, and I intentionally abstracted a little bit. There's no drive names on here, but I wanted to introduce the concept. This is common for any storage device actually, but certainly SSDs. As you start at low queue depth or low I/O load from the application, you have some latency to access the data. Typical SSD read latency, NAND flash-based read latency would be around 100 microseconds as shown in this chart. And then as you increase queue depth inside of that SSD, you'll not only get more IOPS, more performance, but you also at some point start maxing out the device's ability to continue to process its I/O, and the latency will increase. So, 4 devices shown here, latency starting about 100 microseconds and then increasing. If I translate from IOPS, or latency versus queue depth to latency versus IOPS, the chart will look something like this, where the dotted line on the left-hand side is a single SSD from a leading performance SSD, which actually happens to be a Mangstor SSD, but that's the typical curve of what others would show. Around 100 microseconds of read latency, and then as you increase the IOPS load or queue depth on that SSD, you start heading towards the device limit for this particular device is 900,000 4K random read IOPS, and you can see it looks like I'm getting up to about maybe 800,000 IOPS on this chart as I cross the 250 microsecond barrier. So that's the dotted line for a single in-server NVMe SSD that's actually best in class in the industry. And now, the solid line is and this is actually measured data, this is my all-fabric, or my NVMe over Fabrics flash array, where at the far left end you can see there's a little bit higher latency than the in-server latency. So I'm at 100 and change, 110 or so microseconds of latency. But then because I'm able to spread all of that I/O load across multiple devices. To the application server, it looks like a single device. But back in the storage array, I'm spreading it across multiple devices so I can continue to have very low latency. And in fact, in this particular data set, I'm only using 4 SSDs in my storage array, but I'm able to get out to 2.5 million IOPS, and my latency is still only around 110 microseconds. So while most vendors, and this includes us, right, most vendors specify to their customers the latency at the left end of this chart and the bandwidth at the right end of the chart, the reality is that most applications live somewhere in between, right? And so if you're a high performance application, you're probably not going to be doing queue depth 1 IOs all the time. And so you can actually take advantage of much higher IOPS as long as the latency doesn't go off and cause you problems at an application level. And so this chart is exactly why I make the assertion that NVMe over Fabric in the real world, in deployment, in real applications, is higher performance than local SSDs in a server. Okay, so NVMF is the new fast, and that's comparing an in-server SSD to the Fabric attached. What about versus fiber channel or versus iSCSI or SAN? So we've had SAN all-flash arrays in the market for a number of years now from various companies. Here I somewhat abstracted, but I tried to draw what I think is a fair, typical representation of a small fiber channel array. So if I had a 2U box that had, say, 4 fiber channel ports and it was 16 gigabit fiber channel coming out of it, that probably is going to deliver up to about 4 gigabytes per second of bandwidth, and starting at latency just under 1 millisecond. And we've already looked at the chart of our storage array, which is, again, 4 ports. And the latency, you can see, is almost 10 times better, 1/10 the latency, and the bandwidth is significantly higher. Now, if you want to complain, this is 16 gigabit fiber channel to 40 gigabit Ethernet, and you want to talk about 32 gigabit fiber channel, then I'll talk about 100 gigabit Ethernet. But I think that the story is pretty solid, that NVMe over Fabric, if you're on Ethernet or a fabric like that, is going to be pretty high bandwidth, but the latency is really, really the important point. So what do you get? You get super fast results. You can actually do bigger databases, more work done with fewer compute resources. And by the way, this is one of the biggest value propositions, is if you can get, if a CIO says, I can get the work done that I need to do with fewer servers, I save money on the servers, but more importantly, I buy fewer software licenses and save even more money. And then the data scientist is happy because he keeps up with a fast influx of data and he can really analyze it at the same time. Okay. Where does it fit in the market? We've been used to seeing 3 tiers of storage for years, tier 1, 2, and 3. Over the last couple of years, more and more people are talking about tier 0 as the super fast tier. And if you're doing tier 0 in your servers, everybody's doing SSDs for tier 0. And that's kind of the space where these fiber channel iSCSI flash arrays have fit. What we're seeing is that in that tier 0 in server storage, it's all moving off of SATA and SAS onto NVM Express. And that's why when you walk the showcase floor this week, you see all these servers where they're talking about more slots for U.2 NVMe drives in the front because of this factor that it's real and it's helping customers and it's really taken off. On the array side, similarly, we see these SAN-based arrays really being pushed down into tier 1 as the NVMe arrays take over the tier 0 space storage. So application-wise, where does it fit? Certainly any kind of HPC application. And someone earlier was asking me, what's the big show for you guys? Obviously, Flash Memory Summit is a huge deal for us, but the HPC show, whether it's the one here in the US or ISC in Europe, is a big show fit for us because of all these HPC applications really across the board. And then database applications. Anytime the database application has a real-time or time-sensitive nature to it, then it's a perfect fit for NVMe over Fabric. And then sort of as more of a vertical, there's a lot of government applications, which in many cases fit into the HPC or database from a horizontal perspective. Gartner Hype Cycle. Most of you will be very familiar with the Gartner Hype Cycle that talks about technologies moving through and getting to some peak of inflated expectations, and then everyone's disillusioned in the trough. And if it makes it through the trough, then it goes into productivity phase. So this is, used by permission, the 2016 Storage Technologies Hype Cycle from Gartner. And when I looked at it, I said, wait a minute, NVMe is not on here anywhere. And so I asked them about it, right? And here's what they said. They said NVMe SSDs, in fact, have gone through the trough. They're past the trough, and they're working their way out, and you're going to be out into this plateau of productivity where basically there's no other technology listed out there in plateau of productivity. So we're doing pretty well with NVMe SSDs, especially when you consider the fact that, if I'm remembering history right, it was about 3 years ago that we at this conference were talking about NVMe in a big way, and most people we're trying to figure out what the acronym stood for and what it meant, right? And that's the people that are developing the technology. But now from an analyst perspective, end user perspective, it's already through the trough and it's going well. So that's really great. Where's NVMe over Fabric? Well, per Gartner, they say, oh, that's what we're talking about with this shared accelerated storage, which is over here in the brand new phase, right? And so the call to action for this audience is to play the same game again that we did with NVMe and just blast through this peak and trough and drive this thing into the plateau of productivity. So how did we do it? The first thing, the way that we did it, I would say, was there was really 2 big factors. One was, well, number one is just a good technology. It solves real problems and it has real value to the customer. And then number 2, we all got together, we created the standard, we had compatible products and had multiple source availability. Well, those 2 factors applied equally well to NVMe over Fabric as they did to NVMe. So I see no reason why we can't be on a really fast path with NVMF and really surprise the Gartner guys at how quickly it moves through their hype cycle. Let's talk a little bit about example solutions. So from an example solutions perspective, if you walk the showcase floor this year, in past years, you probably saw a lot of add-in cards. This year, still some, but not as many. Much more emphasis on 2.5 or the U.2 form factor, as it's called, or on the gum stick 110 millimeter and 80 millimeter M.2 form factor cards. So you saw all of those devices, and then you saw multiple different server form factors that they were plugging into. In this picture, I show the server, the 3 form factors that Mangstor has in production. We have a 2U chassis, we have a 4U chassis, and then we have an 8U that's kind of HA chassis. So if you'll bear with me, I'll spend just a minute talking about the products that we have. So on a chart here, I show the capacity on the horizontal versus bandwidth of those 3 arrays. So we deliver 12 gigabytes per second and up to 32 terabytes in this 2U, and then you can kind of see where the other ones play out. In the blue boxes, blue ovals, I tried to show what's the sweet spot of application for each of these that we're seeing in the marketplace. So certainly database and real-time analytics, this 2U box, which is easy to deploy in multiple numbers, that's really a sweet spot there. The 4U, which has more SSDs in it, more capacity and more bandwidth. We're seeing that more in a sort of a HPC context with burst buffer as one specific application. And in many cases, these are people who are already doing GPU computing and want to have some high performance storage to go with it. And in the far upper right, that's sort of a fully redundant, hot pluggable, serviceable, no single point of failure in a box kind of application. From a design perspective, and we do also see some people actually deploying Windows storage spaces on that as a really great platform. And so I should say, sorry. So if you take a bunch of those 2Us, that inside of a 42U rack, allocate a couple of switches in there, and then plug in 20 of those things, you get 640 terabytes and 240 gigabytes per second of bandwidth into that. So some pretty big numbers. And if you were looking at these numbers, 2 or 3 years ago, it would be jaw-dropping. We've been shipping this for almost a year now, right? Standard compliant for the last 2 months, but in production for quite some time. And so just next level click down on a couple of applications from a burst buffer perspective. If you're in, an oil and gas guy, for example, and you've got all this research data that you're storing in a Lustre file system, you're trying to pull the data out to your compute servers to analyze it and make some decisions. The Lustre file system and this back-end storage that it lives on is just too slow. It's slowing them down. And so that's a real customer problem, not just oil and gas, but anybody who's doing, say, big data with a Lustre or NFS file system. So this burst buffer concept has come into the market. It's pretty popular. There are some other storage providers who are doing burst buffer. We have a burst buffer solution, and as far as I know, we're the only burst buffer solution that's using NVMe over Fabric, and therefore it's much faster than the other burst buffer solutions that are out there. But the use case is post-processing of large simulation jobs, visualization and analysis. And then the benefits, right? I mean, why it's helping is it's fast temporary storage, and it also is a staging area for large input files. But the one that actually kind of surprised us as we started talking to customers, this was very important to them, and while it's obvious, we didn't realize how important it would be. The last one here is persistent fast storage. So when they're running these big jobs, there's a gigantic file that they have to pull off the file system into the burst buffer. And so then they'd analyze this for a while, and then they're going to come back maybe the next day or sometime later, and they want to run another analysis. And in many cases, what they're having to do today is reload the data from the file system because they had it in memory, and they lost it when they went through a reset of the servers. So being able to pull it up into non-volatile storage and have it still be there for multiple iterations of the job is pretty valuable. Second application, data capture and analysis, and there's sort of 2 use cases buried under this. One is, say, a video capture and analysis of that. The other one would be something in the high-frequency trading financial analysis space, where there's all kinds of incoming data and the analysts are trying to decide how to make their trades. In either case, and the case here was more of a video case as shown, high-speed input data source where the customer wanted to have 20 gigabytes per second of write bandwidth and simultaneously have 40 gigabytes per second of read bandwidth to multiple workstation clients that are accessing these data as it comes in to make some real-time decisions and real-time analysis. And then, of course, they needed to have a large buffer space in order to hold all that data. And so NVMe over Fabric is perfect, number one, because it provides this simultaneous read and write bandwidth. Number two, it's easy to scale. If they needed half this bandwidth and half this capacity, just populate half the storage arrays. Or if they need twice this, just add more. So as long as you have sufficient switch ports and switch bandwidth, you just add more storage arrays and your performance and capacity go up. Let me come back to my picture that I showed earlier of the NVMe over Fabric diagram to talk about something that Mangstor announced this week. So on the left-hand side is the client server with its RDMA NIC. On the right-hand side is the storage array with the NVMF target software. The NVMF target software that we've developed, that we've been in production on for about a year, we call Titan. And what we announced this week is that we're actually making Titan available to OEM partners so that we see it proliferating across the industry. And I actually want to just share a little bit more detail about what the Titan storage software does. You can see at the bottom layer, there's this intelligent abstraction layer that manages multiple storage types. And so it's NVMe devices, and in fact, it can also handle non-NVMe devices while it still presents an NVMe over Fabric interface back to any attached clients. So it's possible now to do tiered storage within a single storage array, take advantage of all those benefits. And then it connects, this abstraction layer connects to network resources, RDMA of various types. And I show Ethernet InfiniBand here. Mellanox has been a great partner from us. That's the lead NIC that we ship, both in the Ethernet and the InfiniBand space. And then there are some other RDMA NICs that are in process in the industry, which we'll support as they come out. On the left-hand side is this REST API. So it's a scalable REST API to manage all the resources, which allows us to provide both a GUI and a command line interface and scripting capability to our customers to manage many storage arrays. So it's a cluster-based management, and in some ways, the mentality of how the management paradigm works is like people are used to with doing large cloud-based computing. So if it's, think of an AWS console where you're trying to manage a lot of servers, that's the way you need to think about managing a lot of storage arrays, which we're doing. And then lastly on this slide is the target data services layer at the top, which includes some things like WAN replication, Lustre optimizations, and the SSD tiering. But also I want to specifically highlight the SAN bridge because that is another announcement that we made this week. And in that case, we actually have announced what we call SAN Connect. And the whole point of SAN Connect is you have this new infrastructure, potentially new servers, or maybe it's servers you already had, attached to the new NVMF storage, but customers still have their existing storage. And so how do you connect to existing storage? So SAN Connect is solving exactly that problem. So with a bridging device with SAN Connect inside, you can see simplified from the picture here, that you can connect your NVMF fabric and storage to the existing SAN-based storage, whether it's Fibre Channel or iSCSI, and then the NVMF devices act as a caching front end, if you will, higher performance caching layer of existing SAN storage. All right, so what's in the future? I just have a couple of slides in this space, and because there's a couple of things I want to make a point about. So we just saw some really cool stuff from Crossbar about faster devices coming. And of course, Intel and Micron have, over the last year, been making a lot of noise about 3D XPoint. And so it's really common, anytime I talk to a customer or potential investor, since we're a startup, they say, okay, what do you guys do when these faster non-volatile memories take over the world? And NAND flash is no longer the fastest thing out there. Well, if I come back to my picture earlier of single SSD versus array, and I say, what if that dotted line becomes much lower latency and much higher IOPS? What happens to NVMe over Fabric? The answer is really simple. It looks kind of like that. right? So the storage array just gets faster devices means faster storage arrays. Now, the little bit of latency penalty from the network device is a higher percentage of that latency. And so, the network providers out there need to work with the system providers like us to try to squeeze every bit of blood out of that turnip to bring it down. But the reality is that same factor of where applications live with high IOPS and high throughput is not at that far left edge anyway. So we see the whole concept of NVMe over fabric or NVMF arrays being something that really has a lot of legs to go for a long time through advancing technologies. From a Mangstor perspective, where are we headed? I redrew my picture without the 4U and 8U pictures on it, but to a different scale, obviously. So if you look at this is kind of where we are today, and I said we can deliver that capacity and that bandwidth in a single rack. We're headed towards a product in 2018 where we change the slope of the curve. And what we'll do is we'll deliver a full petabyte, 1,000 terabytes, in a 1U system, and that single system will deliver 100 gigabytes per second, which means at a rack level, just a stunning 40 petabytes and 4 terabytes per second of bandwidth, of storage bandwidth in and out of that rack in one 42U rack. So that's where we're headed, and we're pretty excited for faster devices inside that we can take advantage of to drive that as well. So that's what I have. Thank you for your attention. Thanks for hanging in there. If you haven't already visited Mangstor, we're over in booth 601 for the little bit of time left on the showcase floor. Come talk to us or find us on the web, and let's have some more conversations.